In 3, we have foam forms above a liquid when liquid is stirred or poured. Investigates the change in volume of foam with time. The liquid is poured quickly into a measuring cylinder and foam forms above the liquid. The student waits 1 minute for the foam to settle and then records the volume V at time t, okay, of the foam. So he repeats the measurement every minute. And we have the student plots the data to show how V varies with t. Error bars are given for values of V. Errors in t are negligible. Okay. Draw the best fit line for these data on the graph, extrapolating to the v-axis. Okay. So this means we have to draw a curve, and ideally we should be doing this on paper, but okay, let's see. Looks to be about okay. Look at this. Okay, I think that's sort of okay. Let's try again. Yeah, that looks all right. And so the idea is just to get everything within the error bars, and it looks like everything is it. Yeah, everything's within, and that should be fine. Estimate the initial volume of the foam. Initial volume of the foam would just be wherever that is, and that is 46, 47, 48. 48 cm cubed. And then we have students suggest the foam experiment can model radioactive decay. Must have similar properties to that of the graph of count rate, corrected count rate against time for the decay of radioactive nuclei. Okay, so explain how data from the VT graph can be tested to decide whether foam experiment can model the radioactive decay. So radioactive decay, the we have the graph looking like this, right? Time, and we have becquerels or activity in becquerels, and we have something like t half. We have something like this, and it's 2t. So we have something like this, right? And let's say this is 48, just using the data, 24. And so this is the half-life. And so what we can say here is there should be a constant half-life, right? Uh, constant half-life, or like the decay constant should be constant with multiple data points. So that means if I test this is, for example, 50, sorry, not 50, 48, 40, and around 20, I should get the same time difference. I should get the half-life as the time difference. And so we can check that using multiple data points. Show you, and now they're asking us to do that. Using data from the VT graph and your test from BI, show that the student's suggestion is correct. Okay, let's look. Let's take 48 actually, and let's take 24, comes about here. And so that is 24, right? And that's 280. So let's write that 280 sorry, we need 2 points, right? 0, 48, and 280, 24. And to check, we are gonna have another point. So here the half-life is 280 minus 0 is equal to 280 seconds. And let's take another point. Let's take something like something constant, 30, 31. Actually, no, we need a even number. 41. Let's use 20, 26, 27, 28. Yes, let's use 28. And we need to find 14. Okay, 14 is about this. Okay, so we have 500. And obviously in the exam we should be doing this faster, but I'm trying to show you all the steps. And so our other point is, see, other 2 points, 28, 220. So we have 220 gives 28, and we have 14, and I believe 500. So t half is equal to 500 minus 220, which is equal to 280. And these are the same. So same half life, or we can say constant decay rate. And therefore, or we can even say constant decay rate, and that is constant. So the suggestion is correct. Okay, we might need to check that with the mark scheme. And the student decides to start the experiment when the volume of foam has decreased by 7/8 of its original value. Decreased by 7/8 means there's only 1/8 remaining, right? And so what is 1/8 of its original volume? That is just 3 half-lives, right? That's 1/2 cubed, which is equal to 3 half-lives. And what is 3 half-lives? 3 times 280, which we found here, which is equal to 3 times 280, 840 seconds. That is perfect. Let's see the answer. And of course, we might just need to be in the range of all these calculations. So curve is within all error bars. Yes, that is what we mentioned. 3a, curve extrapolated to v-axis. We did that, and we got 48 as well. And you're allowed within the range of +2. So even if you're off by 1 or 2, you still get the right answer. 3b, workable method, and this is what we said. You can also explain it as such for equal time changes, value of gradient, and this might be a bit too complex to think under time conditions in an exam, so maybe go for simpler ones. And calculations must be from an appropriate method. So we got this right as well. 2 points, 2 data points on a graph correctly uses 3 or more data points, and we used 4. And that led to our statement that foam experiment is suitable. Is there anything else? Half-life is about 280 seconds. Okay, so we got it on the dot. Recognizes that this is 3 half-lives. We did that. 40 seconds. And yep, that is perfect. So that is how we do this question. And see, you're allowed an answer in the range of 280 to 900. So you should be getting this question right, even if your graph isn't perfect.